All right, so when they say something like this here, okay, the angle that we are interested in is going to be, this is the theta that we've always talked about, right? Okay, and that's how everything that we do from our formulas, from our relationships, is all based off of that angle. They will provide that angle by saying something like this. They will say north 30 degrees east. And what that means is that this is your initial trajectory, but you're going to deviate that many degrees towards this direction. Okay, so this can only be N or S, and this will only be E and W. Okay, and this will be between 0 and 90 every time. Okay, so when they say north 30 degrees east, okay, the way I always read that to myself is north, deviate 30 degrees towards the east. Okay, so that would provide this to be 30. So what would our theta actually be here? Theta would be 60, and that would be the 60 that we would use in formulas and relationships, whatever our trig relationships are that we're going to use. The next one here says north 60 degrees towards the west. Okay, so basically they're always going to give you some deviation either to the left of north or to the right of north, or to the left of south and to the right of south. Okay, so I'm always going to give you an angle like one of these two initial ones that we've seen here. Okay, now it might be in the top or in the bottom two quadrants. But now, so I'm going north, but I'm going to deviate 60 degrees towards the west. Now the angle theta that we're normally used to, which is that one right there, what would you call that angle? How big would that be? Be 150, right? Isn't this angle here 90? And then 90 plus the 60 would be 150. So we've got to do a little bit of angle addition here to get the thetas that we're comfortable with or that we're knowledgeable about in standard position. How big? So now this one will be south 70 degrees towards the west. So you're going to head south first and then deviate 70 degrees towards the west, and that's the bearing or the heading that we're going to take. If that's 70, what is this angle right here? That'd be its complement, doesn't that be 20? And then so how big is that angle? Well, that's 180. So the theta that we're normally used to being provided would be, in this case, 200 degrees, right? Okay. The next one is south 50 degrees towards the east. So then I'd be looking at theta being that angle there, which would be 270 plus 50. 270 plus 50 then is going to be, what, 320? Okay, so that's how we would normally be used to that theta. There are other, and I get them mixed up. There is a different, like heading and bearing. If we're in that field of navigation, heading means one thing, bearing means another thing, but they get misused a lot in our terminology and in our practice problems from certain authors. So I'm not going to try to make a distinction between the two, but sometimes, and I'd have to look, to be honest, I had to look it up myself which one it is, but we are used to standard position being from, like if I say 60 degrees, I'm going to go from the positive x-axis, right? And that would be 60 degrees, okay? There is, I want to say it's a bearing. I'm not sure, though. Starts from this true north actually being your 0 degrees, and when they say then 60 would be that. Does that kind of make sense? But they get mixed up all the time because not everybody that writes these questions is using the correct terminology all the time, and that happens from time to time. But if there's any confusion in that, I will make sure that I distinguish them. Anything that I would give you will either say in great detail, north 20 degrees east, something like that, or north 40 degrees east. If I wanted to change, if I wanted you to go from true north, I would tell you somehow in phrasing that using true north as 0 degrees, then let's look at an angle of whatever. Okay, so somehow I'll draw your attention to that. Okay, so now get to this question. Once we understand that, it says a pilot sets out from an airport and heads in a direction of north 20 degrees east, flying at 200 miles per hour. So after 1 hour, he makes a course correction and heads in the direction of north 40 degrees east. It says half an hour after that, the engine trouble forces him to make an emergency landing. Find the distance between the airport and his final landing point. Okay, so starting off, the way you do all these problems is that you're initially going to draw an X and Y axis, okay, and his departure, the place that he started, is going to be the origin. It could be anywhere. Those of you that have worked with vectors in physics, okay, this is all this is a vector question or vector problem from physics. You could put vectors anywhere in the coordinate plane as long as they have the same direction, the same length. They're equivalent vectors. The easy thing to do then is to, with that logic, move them all to the origin, okay, or at least your starting one to the origin. You could move them all to the origin. The way we're going to do it, we're going to put the starting one here. But he starts flying from the airport and heads in the direction north, 20 degrees towards the east. So that's north, that's east. He's going to go north, but he's going to deviate 20 degrees. Is that okay with everybody? Okay. And that would produce maybe that vector right there. Okay. Which is going to be a side of our triangle here in a little bit. Now it says he's going 200 miles per hour. And then after 1 hour, he makes a change in direction. Okay, so I'm going to say that right here, he makes a change in direction. And what I'm going to do is I'm going to put another coordinate plane in here, okay, or another axis, because right there, he's going to make a change of direction. And now it says he's going to go north 40 degrees to the east. Well, that's going to be now, for going north 40 degrees to the east, would maybe be that there. Does that kind of make sense? Okay. Let me kind of clean this up a little, zoom in and clean this up a little bit. Just to talk about them a little bit easier, change the colors here. So this one here, this was 20 degrees right there, correct? Okay, 20 degrees. This here, this angle right there is 40 degrees, okay? It says after a half hour of traveling on this final direction, he has to land, okay? And it doesn't tell us how fast he's going in this final red direction, so we're going to assume that's still the 200, okay? I want to find some distances here, okay? If I was traveling this length here at 200 miles per hour, so rate is 200 miles per 1 hour, and I traveled for 1 hour, how long would that be? That'd be 200 miles, okay? Distance equals rate times time, correct? Okay. This red one, though, I was traveling 200 miles per hour, but I was only doing it for a half hour. How big is that red one? Red one's going to be 100 miles, right? Does that make sense? And he had to land right here. So that's his landing. This was his starting point. The question asks, How far is he from the original position? Well, that distance would be that right there, wouldn't it? Is that a triangle? Now my triangle, I'm going to redraw it here to make it a little bit better. This is 200. This is 100. Okay. How big, if this is 20 degrees right here, okay, how big is that angle right there? Wouldn't that be 20 degrees as well? We have those are alternate interior angles. If we look at the north to south lines, on both those coordinates or sets of axes, the 20 degree angle there and the 20 degree angle there are alternate interior angles. So that's 20 degrees. How big is this angle right here? 90. How big is this angle right there? 50. So we got 50, 90, 20. Angle addition says that's 60 degrees? What is this triangle? What orientation of parts is that if I wanted to find that distance x? That side angle side? Can I say x squared is equal to 200 squared plus 100 squared minus 2 times 200 times 100 times cosine then of 160? Does that make sense to everybody? Okay. So all these bearing and heading questions, once you get the picture set up, and I know it might be a tedious task of finding what those angle measurements are. That's usually where people struggle the most. But once you have them, everything sets up as a side angle side situation. You can use law of cosines. Make sure my mode is in degrees. I'm going to call this distance C, and I'll take the square root of that. I'm 296 miles away from the starting point, which should make sense to us. Is that, the two numbers that we were using were 200 and 100, so they have to add to be something greater than the third side being 296 now. And because that angle, if that was 180, if that angle was 180 degrees instead of 160 degrees, it would be a straight angle, right? And the total distance would be 200 plus 100, which is 300. So 160 doesn't deviate too much from 180, so 295 or 296 makes sense as an answer here. Okay? So I'm gonna write here, I'm just gonna approximate, I'm gonna just say 296 miles. Okay? Now the next question asks us, well, what is the heading? So let's say that maybe this plane like crashes or lands in the wilderness, and we have to have somebody, we know they've traveled 296 miles, okay? But if I want to find them, I don't know now, if I'm going to start from this airport, and I knew that they traveled 296 miles, well, that's 296 miles that they could be anywhere on that circle. Does that make sense? Okay? So I need a direction to be sent. So what we want is, what is that angle right there? Okay, what is that red angle? Well, I know that it is at least less than 70 because I know this angle here was 20, correct? So what we're getting at here is, can we figure out, why this won't let me change colors? Can we figure out what that angle right there of that triangle is? Okay, so if we come back over here, now that we have all that information, we should be able to say that the sine of 160 over 296 should equal, I'll just call this angle A here, the sine of A over 100. Does that make sense? Cross multiply 100 sine of 160 is equal to 296 sine of A. So then A eventually, we're going to do this all at once, it'll be 100 sine of 160 divided by 296, and then we'll inverse that. Now if I type that in, so let's go ahead and do that. Arc sine of 100 sine of 160 divided then by 296, 6.63 degrees. I'm just going to say 6.6 degrees. So that tells me that this angle right here is 6.6 degrees. Is that okay with everybody? Okay. Well, if we look at the question, it says find the bearing from the airport to his final landing point. What that really means is they want a result written something like this here. Okay. So if I want to be able to take this path right here to that landing spot, I need to know what that angle right there is. Well, it's 20 degrees, because that was what the original heading was, right? And then this just deviated 6.6 more degrees. So I should say that I want to go north 26.6 degrees towards the east. And that will make me a line if I travel at 296 miles. Okay? So stay on that heading for 296 miles, and I will get smack dab to the point where they landed. Does that kind of make sense? So there's a lot of stuff there. I'm not going to ask you a lot. I might ask you to find the 296 on the test on Monday on a question like this. I would not ask you right now to find that bearing of north 26.6 degrees east. Does that make sense? I think that's asking a little bit too much with only seeing one example. But once, and maybe I'll even start with the picture for you drawn out, because I know we haven't seen too many examples of this. If I were to give you, I don't even know if I'm going to give you one of those yet. Does that make sense? I kind of want to see what kind of questions I get over the next couple of days in regards to these before I finalize that. It's going to be one of the last questions on the test, whether I give it to you or not. Does that help? Okay, so a lot of your 5.6 and 5.5 questions in WebAssign are story problem type questions. Okay, if you at any time are struggling with those over the weekend, don't hesitate to reach out and ask questions. But what I would do, and this has always been there, if you're on Schoology, it's in each chapter or in each section. If I go to 5, 6, it'll take me to, so this link right here at the top of every section will take you to my website that I've used in previous years. If you go to law of cosines, okay, you can see right here, this is WebAssign in the background, and that's going to be some questions that are in your homework. Does that make sense? So you can, if you struggle on them, maybe that's something to look at to assist with. And there's a lot of those videos down here at the bottom as well. Okay, and under 5.5. Do I know the answer? Let's see. No, this didn't get that far. Maybe this one. That's me too. No, that one doesn't get that far. These though, yeah, those are very similar. This one here, it's not me, but it's a very similar question. Um, these are just basic, no story to them. If you have questions over that one, I'll work it out and I'll send you what the answer should be. This here is an app that kind of shows you like you can move this around and it'll show you up here what the relationship is between the angles and how they describe it. Then that might help. Does that make sense? No problem. Yeah. Yep. Yes. All right, guys. I want to talk about one or if we have time, maybe two questions that are at the end of 5-6. Okay, just basically want to demonstrate that, and a lot of your questions that you might see or have trouble with in WebAssign and these homeworks are going to probably, I would argue, to be the story problems. Okay. Yeah. But I want you guys to realize that when we see those story problems, the end all goal is to basically see if we can model a side angle side or an angle side angle or whatever may be the situation that will then elicit to use the law of sines or law of cosines. Okay. We mentioned yesterday, we talked a little bit about how vectors worked in physics and how law of cosines will be the tool that we use with vectors in physics. This is essentially a vector question. Now, what stinks about this, and this is all college algebra, pre-calculus, trig type courses do this, or textbooks that you would look in, they start doing things, they start using vocabulary that they assume is like common knowledge. Okay? When they say bearing of 25 degrees, or down here it says bearing of 100 degrees, they assume that you know what that means. Anybody know what a bearing of 100 degrees looks like? Anybody know what, if I said bearing, take a guess at what quadrant a bearing of 100 degrees ends up being in? No. Nope. Nope. Yes. Okay. So what I'm getting at there is you know 100 degrees, and a good guess would maybe say quadrant 2. I think that's probably the best guess. But the structure is a little bit different because of that field of aeronautics, or in this case, nautical field. The way that we deal with angles is a little bit different. They have a different, we go from standard position being the positive x-axis. When I still talk about a bearing, it's actually the positive y-axis, or the north direction. So that's something to think about. And also, you're going to see questions that say like north 30 degrees to the east, okay, as an angle. Okay. Does anybody know what quadrant that stops in? It'd be in quadrant 1. But the angle of theta that we're comfortable with, that we use most of the time, is not the 30 degrees. The way this is set up is that this first degree here tells you to basically say, I'm going to start at the origin and I'm going to face north. Okay? But then you're going to rotate 30 degrees towards the east. So 30 degrees is actually that. Does that make sense? So what would the theta that we're usually, our standard position angle that we're usually used to? 60 in that case. Okay? If I do something like south, 70 degrees east, okay? So again, the first number can only be N or S, and the second number, or sorry, first letter, can only be N and S, and the second one can only be E and W. Okay? So now I'm going to face south. Okay, I'm facing due south, and I'm going to rotate 70 degrees towards the east. So now I'd be looking at maybe that being 70 degrees. Does that make sense? So what would the theta? Okay, so this angle here would be 20, right? But the theta that we're usually used to would actually be 200, right? Okay. The bearing that they would be talking, if they use this notation, south 70 degrees east, the bearing would actually be, I believe it'd be 250. It'd be from true north. Okay. I've got a GeoGebra that I've made. If you guys go to Schoology, I know I've mentioned this recently. Every time, and I know you guys probably don't use my course of Schoology very much because you're in the course and getting exactly what I post there. But if you go to any of the sections above, each section right here will have a link that takes you to the chapter on my website that I've built that has a lot more information on it. Okay, and it's broken up into sections again. So let's go. We go to law of cosines there in 5.6. Scroll to the bottom of this. Obviously, so it's just more videos. Okay, more examples. But here is something I built to show you and demonstrate what, like north 60 degrees, 62 degrees, east, what they're referring to with that 62 degrees. It's that angle right there. Does that make sense? Okay. If I click this button, it will show how they describe that in regards to a bearing. Okay. So when they say 62 north 62.92 degrees east from point A, that is the same thing as saying a 62.92 degree bearing. And the reason they're identical here is because they're both in the first quadrant. Okay. But if I put B down here, okay, now the way that this works is that B is south 66.962 degrees from the east. Okay, or towards the east. So the 66.962 number is this purple angle, right? Does that make sense? Start south, deviate 66.9 degrees towards the east. Okay. The corresponding bearing that would give me the exact same trajectory, the exact same red segment here, would be identified as 113. So when I said, what would a 100-degree bearing be, that's actually this red angle. Does that make sense? Okay. Sine, cosine, tangent, all that stuff is still consistent. It's just how we position our initial ray, essentially, per the terminology that we use. Okay, so that's what we're talking about there. The one that we said, I think, was 70 degrees this direction. So I said south 70 degrees west. You see that does end up being a 250-degree bearing. Does that make sense? Okay. So those things are just little caveats of questions that obviously textbooks don't get into. There's not an excerpt that says and explains how bearings and headings work and how we do those things. It's assume that you know it. Okay. I think it's a bad assumption. Okay. If you look at the practice test, the last two questions, there's one of them that asks and talks about bearings and headings. On Monday, if I'm to give you one of those, I will make sure that does not end up being, the way I present it to you will not be an issue for you completing the problem. Does that make sense? Okay. We will attack this again when we get to vectors, and then when we get to vectors, we'll spend a lot more time on that heading and bearing terminology. Okay. What I did last class is we went over this question here with the airplane. Okay. And I recorded that, and then we ran out of time to go over this one. But there were questions about this one. So what I would like to do here is actually go with you guys, go over this one. I'll record it, and then I'll publish both first period and second period, or second period and third period recordings, and you guys can go back and you can watch this one, and then second period can come and watch this one. Does that make sense? Okay, so this one says 2 fishing boats start from port. Okay, one travels 15 nautical miles per hour on a bearing of 25 degrees. The other travels 18 nautical miles per hour on a bearing of 100 degrees. It says, assuming each maintains its course and speed, how far apart will fishing boats be after 2 hours? All right, so the way you're going to do all these problems, You're going to initially start with a coordinate plane, okay, an XY axis. And you can start these guys off anywhere you want, okay? And if you go back to physics, what you guys talked about with vectors, basically what's going to happen is these so vectors are line segments with a direction, okay? And if I have that as a vector right there, then what we learned hopefully in physics was that that is the same vector. They're congruent or equivalent vectors, okay? So we can move them anywhere we want to. So logically, the best place to move them is where one of them starts, or one of my endpoints starts at the origin, okay? So that's what we're going to do. Two boats are going to start right there, okay? One is traveling at a bearing of 25 degrees. So going off of what it meant by a bearing, that angle there would be 25 degrees, okay? The other one was at a bearing of 100. So going off of that notation, 100 degrees, that bearing would be that. Does that make sense? Is that okay with everybody? Okay. Now it says one of the first one, the blue one here, was going 15 nautical miles per hour. Okay, you ever heard somebody say 15 knots? Okay, that's what a nautical mile per hour is. So that one's going 15. This one's going 18. And they are traveling for 2 hours. So how do I find that distance then? Because that's what I want. I want a distance here. Yeah. Okay, so distance equals rate times time, right? So this blue one is going to have a length of 30. And this red one is going to have a length of 36. Okay. The question is then after 2 hours, how far apart are they? Well, now we would be after 2 hours when they come to a stop. Wouldn't that be that dotted line right there? Okay, so I'm going to take this. Once you get the triangle set up, I think this is messy. There's a lot of stuff in there. So what I'm going to do is just redraw that triangle, but without the coordinate plane. We know that this is now 36. We know that this is 30. Do we have a way of determining what this angle 100 minus 25? Is that okay with everybody? Okay. So this angle here would be 75 degrees. Is that all right with everybody? Okay. And you can do it a different way if you want. You can say if that's 25, then we know this here, doesn't that have to be 65? And if we knew that this right angle here was 100, then because of the right angle down here in the fourth quadrant, then this angle there has to be 10. 65 plus 10 then gives me 75, right? It's just a law of cosine question. Side angle side, that's all that is, correct? Okay. So we're going to take and find x squared is equal to be 36 squared plus 30 squared minus 2 times 36 times 30 cosine of 75. I'm going to 36, 30, so when you do that, okay, x squared, I call it c here, ends up being 160 or 1,636. Remember that's the distance squared, so you got to take square root of it, and it gives you 40.45. 40.45 nautical miles. So you're facing north, and you're going to go 60 degrees to the east. So that top angle. So let me pull that up real quick. I should have it. Just a second. So in this one, I'm going to say north 60 degrees east. Here's our north. That would be the 60 degrees. So then this angle here would be 30. Does that make sense? Jim, what was your question? All right, so I should have looked at this before I looked at it before I gave it to you, but I think this, for whatever reason, I believe there's some, this happens from time to time when I transfer things over into um, Word documents and then they get changed to PDFs for whatever reason, because I use a math type to put these equations in here. This is I'm really only asking, or I should only be asking, the sine of arc tangent of x. I don't know the reason for the duplication there of the sine. We could, but that's going to be, I don't know what. I'm only on the test on Tuesday. I'll only ask that there. Say again. Number 4. Yep. I apologize for that. That was an oversight by me, and I'll have to email. Do you want to talk about how to do number 8? Okay, so negative 4.2. So is that degrees or is that radians? That's radians. So then we're going to go negative 4.2 times. So if it's in radians, then we want the pi down here because that's pi radians there, right? We want 180 degrees there. So this is radians. So that 4.2 radians and this radian will cancel out. And all we've got to do is multiply that out. So we'd be looking for it'd be negative 4.2 times 180 over pi. We'd be looking for that number right there. And if we wanted to, I could ask you to put it into a positive angle. And all you would have to do is add 360 to it. If you wanted to positive 120 and 19. But that's all there is. And the reason I put that on there is because something like this is, when we always see radians with the pi on it, right? And with that, it gives us the idea that because we can visually see pi as essentially a factor here in that number, it reminds, it's radians, I need to change it to degrees. Here, that pi is still a factor. I'm using the word factor loosely here. Is a factor of that 4.2, but it's already been multiplied in there, right? Okay. So maybe I can see it this way. Let's go. The way we figure out what that is I think 4.2 divided by pi. 1.3. So really what I'm showing, when I say negative 4.2, I'm really saying negative 1.336915 times pi radians. Does that make sense? Okay, because that's still the negative 4.2 number that we're looking at. But that has already been multiplied through, and we're just presenting the negative 4.2. So just a reminder, just to clarify, question 4, that should only say cosine one time in the directions there. Jimmy, did you see any others on here that happened with? Question 5, that should only say cosine 1. Anything else you guys want to talk about? Yeah. So doing this one, we got, again, we want sine of arc tangent of x, okay? So this is a practice in deciding what is that input value? What does that represent for an inverse? And there's several things. Not only are we talking about obviously being able to do the work, but also know the vocabulary, okay? Arc tangent is the inverse tangent, right? So what is the input for my inverse function? That's a ratio, right? Okay? And because it's tangent, it tells me it's the opposite over the adjacent, correct? Okay? So when I draw a picture here, okay, remember what the output is for, if the input's a ratio, the output is an angle, correct? So the angle is what is going to take this place after I place x and 1 in the correct spots here, okay? So because it's tangent, that's opposite of adjacent. So it's saying the opposite side is x, and the adjacent side is 1, okay? Now, because I don't know what x is, I can't tell you directly what that angle right there is, okay? If I knew what x was, let's say x was 1, I would know, I could tell you that the output is 45 degrees, a specific number. But I can't do that. I can only tell you that the output here is theta. Does that make sense? So then, this thing here in blue, that right there, arc tangent with an input of x, gives an output of theta. So now I ask you, well, what is sine of theta? So that's how we work with composite functions, right? You evaluate the innermost function, okay, and then substitute that, and you keep working your way out. So now I'm out of sine of theta. Well, what's sine of theta? What's the ratio of sine of theta? That's opposite over hypotenuse, right? How do I find this hypotenuse here? The Pythagorean theorem would tell me that it's the square root of 1 squared plus x squared, right? So sine is opposite over hypotenuse. If you just leave it that way, that would be fine. Okay. But that's what they're looking for there for that problem. So now let me ask you this, and this is how I would check this. We started with the sine of arc tangent of x, correct? Okay, now I'm going to do this in radians. Okay. If we type in, that is what we wanted, right? Sine of arc tangent x. So then we've got x divided by the square root of x squared plus 1. Does it give me the exact same graph? Okay. And what's nice about this is, what did it do? It that relationship changed a trigonometric equation, a transcendental equation, into a purely algebraic equation. Does that make sense? With just x's and y's. All right. If you have any questions over anything else that remains in there, don't hesitate to reach out to me. I have 6 periods free. Talk to one another. Use my website with videos. Okay. See ya.